Hello, welcome back. Today we're going to be going over SFML, the Simple and Fast Multimedia Library, specifically the version of it for the C programming language, because it's normally C++, but I kind of like C better in some ways. And if you've seen the previous video or the previous videos on this, this is going back over the first video in this series because I wasn't really happy with the job that I did on that, even though people seem to really like that video. I feel like I could do it in maybe a third of the time. We'll see how long this video is. And also just explain some things a bit better, probably. Be a little less confusing. So if you want to grab it, you would go here to download. No, not that download link. Bindings. And it says here that CSFML and SFML.net are official and the others are not. So you got that going for you. Click on CSFML. It says that it's close as possible to C++ API, but in C style. And also says since it's similar to SFML, there's no tutorial. But if you follow the available tutorials, you can adapt to it very easily. It's a little more complicated than that, and I'm going to show you how to deal with it. One nice thing is that you don't have as many different options you have to go through as compared with the C++ version. There's one for Mac OS, there's two for Windows, depending on what kind of processor you have or what kind of processor you want it to work better with, and one for everything else. So it gives you the source code so you can build it yourself. So yeah, you don't need to worry about all of this with the C version, which is a nice thing. So now we'll go over to Learn, go to Tutorials, go to SFML and Code Blocks and GW, just because that's the one I'm going to build things on. So we're going to start off with a classical include here. And this one include will include other files that we need. And we're going to do graphics.h instead of graphics.hpp because it's C, not C++, and everything is .h. And we've got the folder here that has all of the 64-bit CSFML stuff. Under that we have bin, which has DLLs. You will need these in the folder with your executable in order to run it the way that we're going to be building things here. It also has lib, which has GCC and MSVC. Going to be using the GCC versions. And there are again 5 of these that are compiled versions of the headers that contain all the active code that actually does stuff. And those again they correspond with these 5 folders that correspond with these 5 header files, and there's a couple more here, and these contain just a bunch of things. For example, after we do our classic int main, first thing is sf : render window. First step, when you have sf : you can just put in sf and whatever comes after it as one word. That is most likely going to be the name of a file or a function or a set of functions. sf render window, for example, is going to be under graphics, not under window. And it's going to be render window.h. And you'll notice the very first function in this is render window underscore create. But there are a bunch of other ones too. And the way that this goes in C++ is you just call it, and then you specify a variable and some parameters within parentheses like this, because you're calling the default constructor. C doesn't have objects and default constructors and all that. So you need to know the name of the function that you want and the name of different structures and data types. And since it's the very first thing, we can figure out that this is to create a window, and create is right there. And this tells us that it is created as a type of SFRender window pointer. It takes in 4 parameters that have varying data types. The first one is this mode, and we need to set that up. So I'm going to do that first. I'm going to do SF video mode, call it mode, and it's just going to be a set of data in brackets. I forget what this is called, but it's data. 200, 232. That what those data points mean are the width, the height, and the bit depth, which is the bits per pixel. That is what we're going to use to create the window. So now we do SFRender window pointer, just as it showed in there. Give it a name, main window. Set it equal to the function call. So SFRender window underscore create. And then we need to pass in our parameters. First is mode. Second is a title. This says SFML works, so I'm going to say CSF, put it in quotes, CSFML works 2. And then there's a style that is an SF uint32. The styles are enumerated elsewhere. The thing to remember is that SF default style has minimize, maximize, close, resize. This is stuff that you expect from your average full-featured window. So SF default style, and the last parameter just doesn't really matter for us, so we can replace it with null, a null pointer. And sometimes you can do that when you don't have anything to put in that space. Sometimes you can't, and you just kind of need to try it out. So first off, after that, we're going to create a while loop, the main game loop that runs the entire time that the game is running. This will run once per frame. SFRender window underscore is open. Guess what that does? It checks if the window is open. And you tell it what window? Well, the main window. How do we know if the window is open? Well, that is an event that can happen to the window. So up here we're going to create an event, SF event, and that is over in window event.h. And right up the top, SF evt closed. But these are all as event type. And at the end, we have events themselves, which contain a type, size event, key event, SF text event, SF mouse move event, and so on. So we're going to create one, then we're going to create a secondary while loop that pulls the window for events. So SF render window underscore pull event. That will pull, calling it once will pull one event off the stack of events. So, but we're putting it in a while loop. So as long as there is something to pull off, it will run. And once there's nothing left to pull off, it will stop running. Pull event from the main window and put it in, and we're going to do ampersand event. So you need to put the address of the event there, of the event variable. Otherwise, it will do weird things and it won't work. Come on. So I'm going to do if events.type equals sfevt closed and sf render window underscore close main window. But now we need to go and compile. And rather than using the msys command line for this, I found works better using just the Windows command line for it. So we're going to change to the directory. I mean, we're going to specify every directory, so we don't need to, but I'm going to change to the directory repos, games. So there's a whole setup of a compilation string that you need. And I'm going to explain what it is and what it all means. You need to first have the path to your compiler, which if you're using msys2 here, it's going to be msys64 by default, and then mingw64 and bin and gcc. Then you need the name of your C file, so toot1.c here, and hyphen capital L, and then in quotes the path to this directory right here. If you were using Visual Studio, it would probably be a whole thing, different thing, where you would need to include these. But I'm using GCC, so you include the folder that goes to these .a files. And then you have hyphen L, hyphen lowercase l, and then the name of these individual files that you're using. And I think you can do it any order you want. I like to go from system to more specific ones. And you need to specify them without quotes, without the .a, and without the lid. So lib csfml-system.a becomes -l csfml-system. And you repeat that for window, graphics, audio, and network. Although I'm not using audio and network, so I'm going to delete those. Then you have hyphen capital I, and yeah, this is bad for people with dyslexia. You got L and I. But you have hyphen capital I, and then in quotes, the path to here. This right here. Not the inside of this folder. You'll notice it ends with include instead of ending with SFML. Even though this is the only thing in this folder, you would think you could include, use this as the path. No, you want to go one directory up. The directory that contains SFML, which then contains all of these .h files and these folders here, because they many things in there start with SFML slash, and they refer to this directory. So if you start from that directory, then it can't refer back to the directory that it's in by that same name. And then at the end, you have -o and the name of the program file you want to create. So I'm going to toot1.exe. Yep, and I missed a parent. Where'd I do that? Right there. And it'll be a little bit faster on subsequent compiles because caching, I assume. Yeah, I think that went a little faster. Now we have an executable. This produces a window. It does not respond very well to changing size, but you can close it, which if we did not have this and these, you would not be able to close it normally. So let's actually do something with the window now. I'm going to set up a circle shape. SF circle shape pointer, let's call it circle equals, and this, yes, this is what this is doing too, equals SF circle shape underscore create. And when you're just initially creating it, you can't specify anything, any sort of things. Yeah, it says right here void, and that it's created as a pointer. So we create it and then go back and do SF circle shape underscore set fill color of the variable circle, and we're going to do SF green, which is one of a set of colors that are defined in another file. And I'll show you, well, actually right here, there's color.h. They're all defined right up here at the top. You can also do things by components of red, green, blue, and alpha. Do it from an integer that you pass in, various things. But I'll also show you how to find it on here. We go to Learn, go to API Documentation, and then Classes is a really good one. Lists all kinds of things. We go to Color, and it shows you graphics module color.hpp. That gives you a lot of good information. That's telling you that it's under the graphics folder and under the file color.h. And then you can look in that file to find the info that you need to find a specific function or data type or struct or whatever. So let's go back to the program. Alright, so yes, set fill color like it says. It also, we have 100.f here that is setting the size, which is going to be a separate line of code. That's one little downside, if you want to call it a downside really, of using the C binding, is that there's going to be more individual lines of code to do the same thing generally. Set radius circle 100. 100 pixels from the center to the outer edge. So we need to display it. If we compiled and ran this, we would not see anything because all we've done is set up some data in memory. It's all very abstract at this point. The graphics card has no idea that any of this is happening. So we need to do the clear draw display process. This is what you're going to want to do every frame of the game, every game loop, in order to have things draw properly. It's what modern graphics hardware is set up to deal with well. So SF render window underscore clear. We're going to clear the main window and set it to a color of SF transparent. That's a transparent black. So if there's anything behind it, it'll show through. If there's nothing behind it, it'll look black. You can use whatever background color you want here. If you're drawing a full screen of graphics, it really doesn't matter what color you use. You just have to specify something. Do SF render window underscore draw circle shape. And you'll notice here it just has draw shape. If we go back to render window, scroll down, it'll stick out when you see it. Right there. All of these are for drawing different things. Because again, you can't just use a default sort of thing in C. You need to specify a specific function. So we do draw a circle shape, which takes in a pointer to the window, pointer to the object, and a pointer to render states. So main window, circle, and render states can just be null. And finally, display the window. SF render window, if I can type, underscore display main window. And prompts, recompile. And hey, would you look at that? We've got a green circle. But if we resize, it goes all wonky. It does not remain a circle. And I'm going to go a little bit above and beyond. Oh yes, and this here. I'm going to go a little bit above and beyond and add another response to events, specifically the resize event. So else if events.type equals SF EVT resized. And we're going to create a view up here outside of this loop just once. And then use that view to change how the window is drawn, how the graphics are drawn. So we're going to create a float rect. It's a float rect, which is just a way of putting together 4 floating point values in a struct or in a structured bit of data. So float rect view rectangle equals, and we're going to initialize it with all zeros. float rect, and yes, I overlooked it. Rect, float rect, and rect. Also has containing and intersecting. Contains and intersects are really nice because they let you do collision detection with an AABB or axis line bounding box model. So if you have the rectangle that your sprite, let's say, fits within, and usually a rectangle is plenty good enough, and usually you have one handy because you use a rectangular shape to define your sprite, then you can just pass that and another rectangle into this function, and I'll tell you if they overlap, and then you can respond to the collision. Right now we're defining a float rect, and we're using it to, looking at the code here, set a view. That is SFView. I adapted this, I think, from another example or tutorial file that I found. So let's go ahead. Let's just demonstrate one more time. Going to find that learn API documentation, classes, view, 2D camera that defines what region is shown on screen. That is in view.h under graphics. Right, so graphics, view.h. So first of all, we're going to want to not create, but create from rect, which takes a float rect, which is why we created a float rect. So sfView pointer new view equals sfView underscore create from rect view rectangle. And then down here, after when the resized event is detected, we're going to change the view rectangle. So view rectangle dot width equals event dot size dot width. And then we're going to do the same for the height. So what this is doing is taking, when there is an event on the window that has the type of SFEVT resized, look under the size property of that, look under the traits of that to the width property, and set that to the width property of the view rectangle. Which, when you define a float rect, these are given names: width, height, x, and y. So view rectangle dot height equals events dot size dot height. And then we're going to reset the view based on this float rect. We set new view to view rectangle, and then set the view as the active view for the window. SF render window underscore set view main window new view. And while we're at it, I'm going to be a bit more proper and destroy the circle shape to clear its memory after the program has run its course, because all of this stops running once we run this here to close the window. And I'm going to destroy the render window itself. Clear out that memory, which closing a program should clear all its memory and make everything fine. But I've seen some things that say you should do this, so I'm going to do it. And also that it's going classic return 0 to indicate that everything went fine. Recompile. And then run. And you'll notice now the resize, the circle stays exactly as it was. And that is in fact it. If you haven't, please go ahead and watch the second video and the following videos. And I will see you next time.